Okay, so it's day one of the sludge, and you and your lab partner are feeling a little scared, a little intimidated, and not really sure what to do. Here's some good, quick advice. First thing that I would do as soon as I got my sludge is kind of slosh it around inside of the container that it's in and try and figure out, can I make any guesses right away about what I've got in there just by looking at it? And then write those guesses down in your archive. Say, well, just by looking at it, I think, for example, that maybe it looks to me like I've got 2 solids that I can see, maybe 3. I can see a large metallic substance. I can see small grains of what looks like salt or maybe sand in the bottom there, maybe potassium nitrate. I see some round crystals here that look like they might be potassium nitrate. And then you could speculate on what the liquid is based on its color. We haven't really seen a purple liquid, but I did tell you that a lot of these were deliberately dyed. So I might speculate that, oh, well, whatever this liquid is, it's been deliberately colored with some kind of dye. And other than that, there's not a lot else I can tell. But just knowing these things, I can then start to make some decisions. Okay, the first thing that I'm thinking to myself is, I want to get my liquids and solids apart. Hopefully you know what the best way to do that is. I'm not going to tell you. And then once I've got those 2 things apart, I can sort of run a few very quick
tests. I can test the flammability of my liquid, which will help me decide whether or not I've got all inflammable or all not flammable liquids. So what I want to do is get a stirring rod, dip it in to the liquid, and then just run that glass stirring rod through an open flame. Make sure you have goggles, a pegboard, all that stuff, and see whether or not it carries the flame after I take it out. Please don't put the glass stirring rods in the heat for too long. They will break from that much exposure to heat. You only want to let them just be in the flame for a second or 2. That should be enough if you have a flammable liquid for it to catch fire, and it'll go out on its own. That's a pretty safe way to test flammability. If you find that you have a flammable liquid, that's really valuable information. First of all, it helps you know that you have to be very careful when and if you heat this liquid. And it also tells you that, it narrows down what liquid it could be that's making it flammable. There's at least 2 liquids in there. They may both be flammable, or one of them may be flammable and the other one might not be. If it comes back as a negative test, that really narrows down what liquids can be in there. The other thing that I would do is I would try and get 1 or 2 pieces of each solid that I think I see, and look at each of them and see if there are any quick characteristic property tests that you could do to help you verify what you think you've got. So for example, if you think that you have iron, you could very quickly test that out, right, with a magnet. You could do that without taking it out. If you just run a magnet along the outside of this glass, if you have something magnetic, it'll immediately respond to that, and you can tell that right away without even pulling out that piece of metal. But there are other tests that you can do with a small piece of metal. You're not going to want to do density with 1 piece of metal. You're going to want all the metal for that because it's hard to get an accurate density from a small piece. But you could do, an acid test if you wanted to, see if it reacts to an acid. That'll destroy the piece, though. You could do, let's say, put it directly in the flame, see if it's a metal that melts or oxidizes, right? So you could do that. You could also, with the powdery or grain-like solids down there are a number of different things that you could try. If you can get your solid, you could see if it dissolves. You could see if it does dissolve, you can see what color the flame turns from the dissolved solid when you put a splint in it. So you could do some quick tests like that to help you narrow down what you have. If you can narrow down what you have, then you can go ahead and redo your flow chart based on what you think you've got in there. And that might be a very useful thing to do before you actually start doing any serious separating. Most of the separation techniques that we've done this year, you've gotten pretty good at. But fractional crystallization is always a tough one for students. There's a lot of thinking you have to do a fractional crystallization properly. If you get to a point where you've got a solid that you know dissolves, you should assume that solid has 2 or more solids that dissolve in it. This is what mine looked like after I did a series of procedures and got just this sort of white powdery substance. And I assume that this white powdery substance has at least 2 things that both dissolve in water in it. So for fractional crystallization to work, one of them would have to dissolve a lot better at high temperatures than the other. If I had a heating curve, or not a heating curve, if I had a solubility curve, it would look something like this for the two substances. One of them, as temperature increases this way, has a big change in its solubility, and the other one is more or less flat. So it becomes slightly more soluble, the second one. This is number one, this is number two, as I heat up the water, and the other one becomes way more soluble. That's how fractional crystallization works. The problem is when you don't know what the two substances are, and you don't know anything about them, you can't be sure how much water to add, right? I mean, if I knew what these two substances were, I could go look on a solubility chart and figure out how much water would be needed to dissolve all of one, but only some of the other. So you're kind of stuck with eyeballing it. So when you look at this, you could certainly get the mass of it, and that might give you a hint, and you don't forget to subtract out the mass of the weighing boat, right? But I think the best thing to do here is just assume that you have very little of these substances, and so you're going to need a very tiny amount of water to dissolve one and leave the other undissolved. So I would recommend maybe 2 milliliters of hot water. And instead of filtering 2 milliliters through a funnel, right, if you think about it, if you pour 2 milliliters of water through a funnel with filter paper in it, with your little coffee filter in there, most of the water, 2 milliliters of water, is basically just going to be absorbed into the filter. And that's not good because that water contains your dissolved solid, and you don't want your dissolved solid to stick to your filter paper. You want it to go through with your water. So when you have a tiny amount of substance like this, it's a bad idea to actually do a filtration for your fractional crystallization. A technique that I've kind of perfected in the last couple of years to get around this problem is to just use this boat to do the whole procedure. So you'll get the boat, you'll have your substances in it, you'll heat your water however you want to over in a beaker or whatever. You don't need very much, so you don't have to heat a lot. 10, 12 milliliters is fine. And then get yourself a pipette, one of those clear plastic pipettes. And what you can do is you can just pipette up about 2 milliliters of water, which is about halfway up the pipette, out of your hot water. You don't want to pipette more up your pipette because then you'll burn your fingers because the hot water going up into the plastic bulb will actually burn you. So you go ahead and grab about 2 milliliters of water and drop it onto this mixture here. When you do that, you'll get this. You can see that, so I've got this little bit of hot water in there, like about, not quite to the top of the tray. And I give it a little stir with my pipette, at the end of my pipette. And then fairly quickly, right after I did that, what I did was I took the pipette back and just sucked that water back up with the pipette. Now, why did I do that? Well, because that hot water, theoretically, has the solid that dissolves better, number one, is in the water now. Number two is sitting on the bottom of the tray. So if I suck that water back up into my pipette and then pipette it into, say, an evaporating dish, then I'll have water with number one in it, and in this tray will be solid number two. And I can get the water away from the liquid in here by just boiling that over an open flame, because I don't need the water, I need the solid that's dissolved in it. And that should separate your two substances conveniently and simply without too much stress or trouble, and you don't have to involve yourself with the whole filtering process. The last suggestion I want to make is just a general couple of pointers. One is that you have 5 or 6 little test tubes like this. Before you start running experiments with test tubes, you want to make sure that they're dry and clean. That's really important because you don't know what's in your sludge and you don't know what's in a dirty test tube. And if you mix two things you don't know what they are, anything could happen. So make sure things are clean and dry. The main reason that I gave you these test tubes, though, was for solubility testing. They can come in really handy for deciding whether or not a solid dissolves well. I used to use microplates for this, but my microplates, the little plastic dishes that have the little wells in them, they've become really, really badly damaged, and so it's hard to see what's happening in them. So you're better off with these guys. What I recommend to see if a solid dissolves is to put a half pipette of liquid into a test tube. That's water, and behind it I have alcohol. Because alcohol and water dissolve different things. There are some things that dissolve in both, and there are some things that dissolve in only one or the other. And this will help you narrow down what solids you've got. So what you want to do is you want to take 2 or 3 grains, just tiny, tiny amounts of your solid, and put it in there and give it a little shake or stir and a little bit of time before you decide whether or not it's dissolved. Here's what it'll look like. Here's what most students would consider to be a tiny amount of solid, right? This is actually copper sulfate that I have in the scupula tip. And most students will say, oh, that's a small amount. I'll put that amount in. But actually, a small amount is way less than that. It's like that much. So I'm talking about a smidge. If you have a powder, that's plenty. If you have bigger or larger crystals, you still don't want to put more than that amount in. If your crystals are, each one is the size of that little amount that I have circled there, then you just put one. If your crystals are smaller than that, you might have to put 2 or 3. That's all you want, because you're trying to determine whether or not it dissolves. If you add all of this, some might dissolve and some might not, and you may not be able to tell. You might have solid sitting on the bottom. You might have precipitate sitting on the bottom, and you'll say to yourself, oh no, it didn't dissolve. When in actuality, some of it did. You just didn't notice that some of it dissolved. So you want to be careful of that when you're testing solubility. You can also do this in reverse. You can figure out what liquids you have by dropping different solids in them. So if you are testing the liquids that you got from your sludge, you can put the liquids in, just like I did here, and then add things that you know, well, this dissolves in this dissolves in that. Let's see what happens when I add a couple of grains of this solid. Oh, that it dissolved. Well, that must mean that my liquid is blah, blah, blah. So you can do this both ways. Here's another tip for you. I gave you a thermometer that has a stopper around it, and the reason for that was just so that you don't have to hold thermometers when you're trying to find the temperature of something, so you don't have to hold it in your liquid. One of the things you're going to want to heat your liquids for, or heat water for, I should say, is to do that fractional crystallization that I talked about. So you want to see, when you get up to 80 or so degrees. So instead of just holding it there, you can just use you can just use a clamp, and you can you don't even have to insert the stopper. You can just lay the stopper across the top. Sometimes it helps to insert it. Make sure that your bulb is totally below the water. It looks like I'm half in, half out here. It needs to be a little lower. And that way you don't have to stand there and hold your thermometer. When you do this, a good tip is to make sure that you put the numbers for the beaker facing behind so that you have a clear view of your thermometer. And you want to make sure you can see the numbers on your thermometer as well. But be careful with these stoppered thermometers. Those stoppers have been around those thermometers for many years, and as a result, trying to move the thermometer in there is extremely dangerous. You'll break the glass off in your hand if you put any pressure on it. So anytime there's glass stuck through a stopper, a glass bend or a thermometer or anything like that, you should never try to move glass that's in a stopper. I have cut myself more times than I like to admit. I've had stitches many, many times because of this. Please do not risk yourself. If you need to move something that's stuck in a stopper, let me know, and I'll attempt to do it with specialized equipment that I have to protect myself. One last thing, if you're going to do a distillation, and you probably will because you have more than one liquid, you should use 2 or 3 boiling chips. And I did put them out on trays for you, but if you run out, let me know. I'll give you more. 2 or 3 boiling chips in the bottom of your test tube. When you're doing a fractional distillation, you use a large test tube. You should remember, you've tested for flammability. If you've got a flammable liquid, remember that if that flammable liquid escapes, if fumes escape out around the edges of your stopper, you will have a little burst of flame. If that does happen to you, if your test tube goes up in smoke, don't try to grab the test tube. Let it burn. All the liquids that I've used, the ones that are flammable, all have low flash points, so they catch fire easily, but they also don't burn very hot, so they're not terribly dangerous. So as long as you just back away and let it do its thing, that's okay. It's better that you let the fire stand and the pegboard and all that stuff burn than you let yourself burn. You can always let me know if a small fire breaks out. But putting the boiling chips in will definitely help keep things safe. Also, make sure that your clamp that you're using when you're doing a distillation is really secure, and you want to keep that test tube at a slight angle, something like that. And you would definitely want to use a fire stand under it, because that helps to control your flame and not let it go all the way up the sides like this, so it'll keep your flame down here, and that'll help you as well. And you want to make sure that your connections are all tight and everything, and that you don't have any leaks out the top of your test tube, because that's where flammable liquids turn to a gas and become dangerous, because if you have a flammable liquid turning to a gas up here, your flame can have a sudden burst and catch it on fire, and then you'll get this big fire around your test tube. Again, if that happens, just let it burn itself out, and it will fairly quickly. And that reminds me, in general, if you find that you're working with a flammable liquid, you want to keep it away from the flame. So if you have excess liquid that you're not testing at the moment, you want to put that liquid with a lid on it somewhere out of the way. Don't have a flammable liquid sitting in an open container. Don't put flammable liquids into evaporating dishes and then try and boil away the flammable liquid. That is a recipe for disaster. It's a good way to break my evaporating dish from too much heat. If something like this were to happen, again, let it burn itself out. Don't put yourself at risk. I think that that's enough information to get you started on your sludge test. I know that this has been kind of a long tutorial, but hopefully you find it useful. And if you have other questions or things that you want me to make a tutorial about, you can ask me. I'll see if I think it's worth doing. Okay, see you guys in class.